See the thing like Hadoop versus Spark we will discuss first. Both the purpose, the Hadoop or Spark, if you talk about these two things, the purpose of these two systems is big data. But to store this big data and to process this big data, already we have a better solution, that is Hadoop. Then why Spark? This is the question mark. Okay. See, in our basic Hadoop, basically we have two layers. One is for storage. Second thing is process. And if it is storage in Hadoop, you have a special file system called HDFS. But for the processing, you have different things. One is MapReduce, after that MapReduce 2, then DAG, which uses like Tej. Tej is an example for this DAG model. And after that recently is the Spark came into picture. This is also a DAG with in-memory computing. So even though MapReduce 1, MapReduce 2, such kind of advanced systems are there, or these kind of DAG models are there, why Spark is? Spark is basically this DAG model and also like which uses like in-memory computing model, which is very faster in the case of processing. Okay. That means simply Spark is, what is Spark is? Spark is an execution framework. So which is like 100 times faster than MapReduce. And even when compared with the Tej also, this is recorded as very great higher speed. So that is what simply the advantage of Hadoop, that is Spark. So based on this, you can say Spark is not at all a replacement for the Hadoop. Total our data has to be stored and managed by the Hadoop, and the processing is only done by the Spark. That means Spark will fetch Hadoop data, that means HDFS data, and process it in a parallel way. That too in in-memory computing style and DAG style, DAG. The DAG, the new word here, DAG. What exactly the DAG? When we enter into the Spark architecture, you will understand. Till then, just I will give you a full form of it, direct acyclic graph. Plus in-memory computing. These two powers are with Spark. See, before going for this Spark, even though we have MapReduce kind of advanced system, so what are the drawbacks of this MapReduce and what Spark will do to overcome them? These major drawbacks we will try to understand today. That means the MapReduce drawbacks, that means the MapReduce problems we will discuss now. Basically, three problems we have. One thing, the first thing is transformations cannot be reused. This is problem number one. So what exactly later, first let me describe each and every problem. Later that I go detail into the each problem. Transformations cannot be reused. In what way that it cannot be reused? So those things we will discuss later. And second thing is, it's not like a flexible parallelism. That means you can say like limited parallel process. And third important problem, which is iterative, bad for iterative algorithms. So these are the major problems with the MapReduce. Still, once if you understand the Spark architecture, you can say other drawbacks of MapReduce also. But one thing, what exactly these problems? Okay, we will try to understand these problems step by step. I'm taking the first problem, the problem one. The first problem is transformations cannot be reused. So all of you consider here one simple equivalent Hive query I'm giving you. Suppose my query is like this. Select sex comma sum of salary. One simple aggregation I am taking, grouping by the sex and aggregation over the salary from some table. Suppose the table is EMP. Group by sex. See, when you submit this query in Hive, it has to be converted into MapReduce. See, in case of MapReduce, is a two separate processes. One is mapper. Of course, in between mapper and reducer, some intermediate phases like shuffle and sort, such kind of things. Forget about those things. Let's talk about major two processes to do this one. Mapper and reducer. Okay. Now what this mapper has to do? The mapper has to write. It has to take offset number as input key, entire line as input value of your backend file. Of course, we are interacting with the table. Table backend some HDFS directory. HDFS directory is having some data file. So when that file is submitted to mapper, the line's offset number as a key and entire line as a value. That is basic text input format. The mapper will take them, and in the mapper, in the map function, we perform some logic to separate required output key and required output value. In our example, we need to separate from the backend file, we need to separate the value of the sex and value of the salary. And among these two, which is key, which is value? The sex is key because we are grouping the data by the sex. And we are performing aggregation over the salary. That's why salary should be the value. That means this will write the sex as key, salary as value. And later in reducer, once data reaches to the reducer, before data reaches to the reducer, first the phases sorting will happen. And after that the grouping will happen. In the case of grouping phase, all female salaries as one group, all male salaries as one group. And finally we will perform some aggregation. So final result will be like this. Female, the total salary, male, the total salary. Like this, the output will be produced by the reducer. This output will be stored into some HDFS. But what about this mapper? This mapper output is temporarily stored into local disk. Okay, first time whenever I execute this query, internally the query has to be converted into MapReduce. Mapper has to separate sex and salary, and then reducer will finally aggregate them. Okay, this process is over, result stored into some HDFS or into the console, depends on your query. Okay, next I'm going to say one more query. This query is also from the Hive. I'm saying that select same key I'm using. And here my statement is average. The function is average. Average of salary from table name and group by sex. See, now whenever I submit this again, it has to be converted into MapReduce. Again, MapReduce means you have mapper and you have reducer. Now what the work has to be done in the mapper? It has to separate and write. sex as key and salary as value. But here the question is, already when first time this query is submitted, already sex and salary were separated. Again when I said like sex comma average of salary, again it is doing mapper. That means in the case of previous mapper, some small transformation is done, which is separating and writing sex and salary. Again it is doing the same work. That means the previous execution transformation is not reusable into this particular query. Again I need to write this one. Okay. So again, even though the code is already existed, okay, again it has to re-execute this entire process. But what is expected? Already in the first phase, if sex salary is separated, when you trigger the second query, already whatever the sex salary is separated, from those things, the remaining work reducer has to be done. But this MapReduce is re-executing entire data flow of your MapReduce. Okay. So this is what like the fundamental problem. So here you perform in the reducer average aggregation. Again in the third step, if you ask about sex comma max of salary, again the process has to be restarted from the mapper phase. Again shuffling, sorting, grouping, aggregation, entire mapper data flow has to be executed. That means here transformations are not reused. This is one problem. Okay. Or else like there is another solution. Suppose if we suspend reducer, if we suspend reducer, what will happen is the mapper output will be permanently stored into HDFS. Otherwise, mapper output will be temporarily stored into local disk. See, try to understand this problem. Suppose a small query. Suppose in my driver class, I simply said my job. Suppose my job object is J. Set num reduce tasks. I said 0. That means number of reducer tasks is 0 means reducer is suspended. Okay. A simple mapper logic I am writing. Only the map function I am writing. Some long writable K, which is for input offset number, and a text which is V, and I am going to write something context variable. The possible exceptions here throws IO exception, interrupted exception. Suppose my file data format is like this: 101 some name, salary, the fourth field is sex value, and fifth field is department number something. This is what like record shape: ID, name, salary, sex, department number. See, to separate this sex and salary, a simple Java pseudo logic I am writing. String of array W is equal to. First I am converting this text into string, and I am applying split function for that. The splitting based on the comma. When you apply this one, you will get array. I am going to separate this sex value and salary value. Sorry, this salary value. Sex and salary value. Taking that sex variable, which is 1, 2, 3, 4. That means index number 3. By this statement, sex separated. Now, and I am going to take salary value. Int salary is equal to integer dot parseInt of. The W of 2, which is third position. So by these two shots, the required two variables are separated. Among these two things, I want to make it as key and I want to make salary as value. And you are writing some context dot write off, new text of key. The key is sex here, and value new int writable of salary. So map function completed, the mapper class completed. Simply this is what. When you run this query, when you run this job, here already you have suspended the reducer. Now your output will be stored into HDFS. Suppose your output file is like this. Key value. Suppose for the first record the key is M, the value is 20,000. Second record F 30,000 like this. Suppose third record M30 again, F40, M20. Now think that only 5 records are there. Now I want to call this query. Already mapper output stored in HDFS. That means already transformed content is available in HDFS. Now I am giving this query. I am loading this data into some table, or straight away I am writing my MapReduce. I want to write a reducer for sum. So here I keep some sum logic. Or else one more reducer I want to write. The reduce for average. So here I have written the logic of average. Already I have mapper output. Okay. And here I want sum. For each sex group I want sum. For this reducer class. For each sex group I want average. For this is the reducer class. Now if I call some, can I call directly without executing this mapper, because already mapper output is there? Can I directly call this reducer without mapper phase? It is not possible. Even though mapper output is ready, if you give this file as input to your MapReduce job, again mapper has to take offset number as a key, entire line as a value. Again it has to separate these two things. Again it has to write the sex as key, salary as value into the temporary local disk, and then the output of the mapper has to be sent to the reducer. That means even though the mapper output is ready, the transformed content is ready, every time whenever you submit your MapReduce job, entire life cycle of the MapReduce is being triggered. Again mapper has to take key and value. Again by taking the value it has to separate like required key and value. Again it is writing. So this is what the important major problem of the MapReduce. That means without mapper you cannot directly execute the reducer. Every time it has to follow one fixed data flow. That means one fixed data pipeline it is following. This is one of the important problem. Okay. And try to understand the second problem. So once again I am repeating, what is the title you can give for this kind of problem is the MapReduce. Whatever the transformations you did in the previous job or previous processes, that cannot be reused in next processes. Okay. And come to the second one. Suppose I have a file 1. So before that, let me give the label of the second problem. Not flexible parallel process. And even you can say like a limited parallel process. What do you mean by this statement? See, try to understand this one. Suppose I have a file 1. Input file is some file 1. Think that it has 3 blocks or 10 blocks with 3 replicas. So that means like a total replicas here 10 into 3, which is 30 replicas. Now all of you like try to understand this. You have 32 replicas. That means unique replicas are only 10, because block 1 that is for 3 times, but uniqueness is only 1 time, right? Yeah. So when you submit this job, when you submit MapReduce job over this file one, so like how many mapper tasks will be initiated? Of course, the basic idea is number of input splits. Generally for one block, one input split. I have 10 unique blocks. That means 10 unique replicas. So that how many mappers will be initiated is 10 mappers will be initiated. These 10 mappers will be parallelly processing. Okay. Now let me write the same statement. When you submit MapReduce job, number of mapper tasks is equal to, you can say like number of unique blocks. That means 10 tasks will be 10 mapper tasks will be initiated. So these 10 tasks will be running parallelly. So this is basic thumb rule. See, totally you have 10, 10 into 3, totally 30 replicas. Same in Spark, how is the behavior? Try to understand. Just don't worry about this statement. Okay, just try to understand what is happening here. Later when you enter into Scala and Spark, you will understand the syntaxes and everything. A small example. A val some data is equals to. How you have context variable in MapReduce? Here you have Spark context. SC simply. The Spark context object is SC. I want to read it from the text file. I am saying sc.text file. Suppose I am giving some file path. User, my data, think that this is HDFS path. The file name is file1. As per our example, file1 has 10 blocks with 3 replicas. Now, this is one RDD. RDD means the Spark data objects are called RDDs, resilient data distributed data sets. RDD with 10 partitions. And how your HDFS file is divided into blocks, the Spark data objects are divided into partitions. Now how many partitions for this RDD is? This RDD with 10 partitions. Why 10 partitions means you have 10 unique blocks. Now when I perform some transformation over this data, these 10 tasks will be generated. These 10 tasks will be parallelly processed. Of course, here in this point of view, there is no difference between MapReduce parallelism and Spark parallelism. But one little betterment in the Spark is the Spark process in in-memory computing. That means total process will be held at memory. Data loaded into memory, data processed from memory. Okay. So this is what like 10 partitions. But I am not satisfied with the number of parallel processes. I want more number of parallel processes. Observe this second set. I am saying val data 2 is equals to sc.text file. Same file path I am giving. User, the directory my data, under that file 1. Now if I close it, here also same behavior, but I want to make it as 20. Now here each block is divided into 20 partitions. Okay, suppose we have 10 blocks, 10 unique blocks. 10 into 20, totally 200 partitions. Now how much parallelism you can achieve? 200 parallel tasks you can achieve. See, if 10 missions did this work in like 1 hour, if 20, if it is multiplied with 20, 1 hour divided by 20 will be the time. That means you have accelerator for your bike like this. Okay, you can provide flexible parallelism. This is what like very flexible process. You can increase, you can decrease like this. So basically, like for each one block or for each one unique block, one partition will be generated. That is like a default nature of this Spark context text file. If you make it like a 20 or if you make it like a 10, each block is again subdivided into 20 partitions. Now when you perform some transformation, each block will be processed by 20 different machines of your Spark cluster. Suppose 200 partitions, 200 parallel tasks will happen, and which is like more 20 times faster than the regular MapReduce. Still, because of in-memory computing, this is 100 times faster than the previous models. This is what the second problem of the MapReduce. That means flexible. It's not the MapReduce is supporting parallel process, but it is not a flexible parallelism. Okay. And come to the third problem of the MapReduce. That is, MapReduce is bad for iterative algorithms. See, actual Hadoop purpose, if you talk about Hadoop purpose, big data and analytics. Because of this issue, this department, Hadoop came into the picture to process big data analytics in a faster way. So Hadoop came into the picture. But in Hadoop, previously before Spark or Tej, we have MapReduce models. This MapReduce is bad for iterative algorithms. Why I am highlighting iterative algorithms is, if you talk about this advanced analytics, 90% of algorithms are iterative. See here, what do you mean by iterative algorithm is, suppose you have data. Suppose think that you have 1000 records. When you run the query or when you run some job, first data scanning will happen from beginning of the record to end of the record. Finally, later this will be sent to some reducer. Reducer will aggregate it for some final results you will get it. Again, these results has to be applied to the input data. Okay. By taking these results, again data has to be scanned from again beginning to up to ending. Again, one more result you will get. Again, this result has to be applied to the beginning data. At each result, some error will be there. And in the second result also some error will be there. Okay. A small example for this, a k-means is the example. What exactly the k-means when we enter into machine learning we will discuss. Just to try to understand what is a iterative algorithm. Think that you have 1000 records. First I will choose some, initially I will take some random points. Random point 1, random point 2. By taking this random point, I will form this data into two separate groups. For each group, I will calculate centroid here. Suppose the centroid is some 10 and 20. This is centroid 1. And centroid 2, which is 20 and 30. Think that these are the processed results by this in the first iteration, which has scanned from beginning to up to ending. Later I will get these two results. But here there is an error. That's why in the second iteration, this is first iteration. In the second iteration, what I do is, I will remove these random points and I will replace this centroid 1 and centroid 2. By applying, instead of applying random points, by applying these centroids to this original data, again I will scan entire data so that I will get another centroids. Now the latest centroid is like this, 15, 25 and centroid 2 which is 25, 32. Now observe this, second iteration centroids are this one, first iteration centroids are this one. These two are not equal. These two are not equal. That means still here also some error process is there. Again, in the third iteration, I am taking latest centroids. Centroid 1, centroid 2. Again, I am applying to the original data. Again, I am scanning entire data. Final centroids I am calculating. Observe this. In the third iteration, the centroid still 1525. Centroid 2, 25, 32. Now here the error became 0. And why error became 0 is the current centroids are equal to previous iteration centroids. Then the error will become 0. That means I need to perform so many, even if required, hundreds of iterations, okay, till I get 0 error. Whenever error will become 0 means the current centroid values are equivalent to previous centroid values, then my error will become 0. But before submitting this job for my input data, I don't know how many iterations that this will happen. It can happen in 4 iterations, or it may take even 400 iterations, but I don't know that one. Generally MapReduce is good in this context, only for a single iteration the MapReduce is good. Again, by taking the first iteration report results, by applying that results to the original data, again I am rescanning, producing one more results and comparing with the previous iteration results. Like this, for such kind of activities, the MapReduce is very bad. Okay, for this Spark kind of models are very good, because Spark is using DAG models, where DAG is very good for this kind of iterative algorithms. Okay, so once again I am retyping all the 3 problems what we have described. The MapReduce problems, the first problem, which is transformations cannot be reused. Of course can be used, not flexibly. Transformations cannot be reused. This is problem number 1. And second thing, limited parallel process, you can say. And third problem, that means not flexible parallelism. This is a symbol for parallel process. And third one is bad for iterative algorithms. Okay. See, whatever the problems we are here, no, 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 we are saying the same thing is yes, yes, yes in Spark. Based on this, the Spark advantages you can code. Number 1, transformations can be reused. There is a feature called persistence feature. By using this mechanism, you can reuse the transformations. And second thing, very flexible control over the parallel process. Already have seen that example, sc.text file of the file name comma 20. If you say each block is divided into 20 partitions. If I have 10 blocks, 10 into 20, 200 partitions. Now 200 machines will be parallelly processing that one. Very flexible control over parallel process. That means you can increase number of parallel processes. Even sometimes you can decrease. And third problem, is very good for iterative algorithms. Okay, these are the 3 basic advantages. Still other advantages, step by step we are coming to that one. Before going for the Spark components, okay, now we will compare this Spark with different other frameworks. Okay. See, the first comparisons. With other systems. Up to now what we discussed is MapReduce versus Spark. So what are the plus points in in Spark and what the minus points in the MapReduce we discussed. Now let's go with let's compare with other things. Okay, MapReduce versus Spark. Already we discussed this issue. Three problems. These three problems are overcome in Spark. And second thing is Tej versus Spark. Okay, now we will discuss about this one. Let me write the highlights, what comparisons we are going to do. Later I will come one by one. If you talk about in-memory computing, already proven in-memory computing system is SAP HANA, where industry is widely is using this SAP HANA for their enterprise solutions. Okay, so SAP HANA versus Spark. And if I talk about data flow language, already we have very good data flow language in Hadoop, that is Pig. Of course, Spark programming style is also data flow. Now Pig versus Spark we will discuss. Okay, this is in terms of execution. This is in terms of DAG, because Spark is DAG, Tej is also a DAG. In what way Spark is great? And if you talk about this SAP HANA, SAP HANA is in-memory computing, Spark is also in-memory computing. In what way Spark is great again? And Pig is a data flow language, Spark is also a data flow language. Of course, Spark is a framework, is not a language, but Spark's programming style is data flow. In terms of data flow, in what way the Spark is greater, we will discuss now. Today, our final target is at least to understand these four differences, and next class onwards we go to internals of this Spark. That means Spark architecture we will see. Up to now we discussed about the first point, the MapReduce problems and Spark advantages. Now I am coming to Tej and Spark, Tej versus Spark. The second comparison, which is Tej versus Spark. Tej execution model. And also the Spark's execution model is DAG. Okay. But if you talk about the Spark is DAG plus in-memory computing. See, generally, before in-memory computing, when you submit some query or when you submit some job, what is the processing style is your data is already existed in disk, that means file. Disk to virtual storage, that means some part of your hard disk is engaged as virtual storage, which acts like a memory. Okay, disk to virtual storage to the RAM. In RAM, entire data cannot be fit. Okay, that's why some partial data will be loaded into RAM. After that, packets wise the data will be sent to the processor. The processor will process it. Again, results will be sent back to the RAM to virtual. How much volume of data? Suppose previously from virtual storage to RAM, some 4 packets of data has been sent. Okay, once the results got back, another 4 packets data will be resent to the RAM. In this way, the cycling between disk to virtual to RAM to processor, again processor to RAM to virtual. On that way, the cycling and paging processes will happen. A lot of intermediary phases, which is really will consume a lot of processing time. But in case of in-memory computing, data completely loaded into RAM, the cycling between only RAM and processor only will be there. Cycling between only RAM and processor. There is no other intermediary phases. So that's why in-memory computing model is 100 times faster than disk kind of processes. But Tej uses a DAG, which is a new model when compared better model when compared with MapReduce. Okay, but Spark uses the same as a DAG, the same as Tej it is using a DAG. At the same time, the computation style is in-memory computing. That's why it's still more faster than this Tej. This is fundamental difference between Tej and Spark. That's why Tej came into picture but not succeeded that much. Before Tej is going to proven, the Spark came into picture. The Spark has highly dominated this Tej. Okay, and come to the third one. Up to now the highlights when compared with the Tej, in what way the Spark is greater is in-memory computing. But Spark is not the first one who implemented this in-memory computing. Previously some other powerful systems are there. Among them one of the popular thing is HANA, SAP HANA. Okay, so now let's see SAP HANA versus this is Spark. Both are using in-memory computing. See, if you talk about it, this SAP HANA is a server which is not distributed, which is non-distributed. But Spark is a distributed cluster. That means Spark server means not one single CPU. A multiple hundreds of CPUs will be engaged. But if it is SAP HANA, that is a single server. A single CPU is acting as a server. For example, I have 100 GB data or 1000 GB data, 1 TB data. I am talking about HANA. HANA is a specialized hardware. For example, HANA's RAM is like this. I engaged 100 GB of RAM. Okay. Now, when you load it as per in-memory computing, the total data has to be loaded into RAM only. This is just one CPU. SAP HANA means is not distributed, is just one CPU. If I have 1000 GB data, 1000 GB data cannot be fit into RAM if I have like 100 GB RAM. Even though if I configure like a 200 GB, okay, within the limits of 200 GB only, I can keep the data into the RAM. Okay, within the limits, this is faster. Okay, if volume is very greater, nowadays like today, the world is like per day terabytes of data we are getting into the organization. Now, to dump all the data into the memory of the HANA, this is really not possible. Okay, so this is what simply HANA problem. That means up to some limited scale, you can use HANA. But nowadays, the high scale of the data, like per day 10 terabytes. Okay, and so, okay, let's consider this. This RAM using some high-end hardwares, they configured the RAM as 10 TB. Suppose Flipkart is the organization. Flipkart daily is generating around 12 terabyte per day. 10 to 12 terabyte of data it is generating per day. Suppose this 12 TB data if you are keeping into this HANA RAM. Okay, day number 1 is over. What about day number 2? Day number 2 another 10 terabyte you are getting. The HANA's in memory is here 10 TB configured as 10 TB only. That means every day you cannot increase the RAM within the single CPU. So this is one of the major problem with this HANA. But if you talk about this Spark, Spark is a like Hadoop, on top of Hadoop or on top of any other cluster. This is a distributed system. This is a distributed system. Okay. So that means HANA. Okay, sir. Here simple example. I have 4 GB RAM. A simple RAM I am taking. Only 4 GB RAM. Of course, 4 GB is not recommended for the Spark. If you are using Spark, minimum go with 8 GB or 12 GB, such kind of RAMs for each slave. And I have 20 GB of data. If it is single system, I cannot keep 20 GB data into the RAM of this one machine. But if I have distributed system, if I have a cluster, suppose now this 20 GB can be here like 4 GB, 4 GB, 4 GB. If I divide this data into 4 partitions or 5 partitions, okay. So these 5, each partition contains only 4 GB data, right? These 4 GB can be fit into different machines. So still data is more. If I have 100 slaves, 100 into 4, up to 400 GB I can load into the system. So this means HANA is a distributed and parallelized. Sorry, not HANA, the Spark is. Spark is distributed RAM. Up to now distributed storage you have seen. Now this is a distributed RAM and parallel process. That too in DAG style. That too with in-memory computing style. This is simply the Spark is. What is Spark means? Spark is an execution framework which supports distributed RAM. That means your data stored into RAM means not in one single CPU, that is distributed into different RAMs of different slave machines. And when you trigger some process, the processing style is parallel. That too it uses DAG model, not MapReduce. That too, the total processing, the computational data loaded and data computation happens at memory, that means RAM. Because of all these reasons, the Spark is super faster. Already which is proven record is Spark is 100 times faster than MapReduce. But in some cases, the in-memory computing process is not recommended. Suppose if I have only 5 slaves, of each slave capacity 4 GB, total my RAM capacity here 20 GB. If I have 100 GB data, of course you can scale up the server capacity, cluster capacity, but I don't want to scale up now. I want to run with only 5 GB, only 5 slaves only. Each slave is having 4 GB, but I have 100 GB of data. I cannot scale up now. Okay, in this case, the in-memory computing is not recommended. In this kind of movement, forcefully I will come to disk computing. That means I have provision. Some processes I will do from in-memory computing style and some other process I will do in disk computing style. But still this disk process, because of the DAG, when compared with MapReduce, 10 times faster than the MapReduce. In memory, like suppose if we talk about reducer entire activity is done at in memory only. When compared with the reducers in memory of the MapReduce, the Spark's in memory computing style is 100 times faster. Okay, so let me write those two key points. In memory, that means in RAM, 100 times faster than MapReduce. The same thing in disk. In disk wise, if you compare, disk computing style if you compare, this is 10 times faster than MapReduce. See, if you talk about this one, what is the reason for this is only DAG and in memory. If you talk about this one, only DAG is the reason. Okay, I feel that memory space not sufficient. That's why I'm forcefully triggering my process to be done in disk style. I can use this process also. Okay, that means I have flexible mechanism in Spark. Sometimes I can choose RAM, sometimes I can choose disk process. Okay, but even though Spark existed, why Hadoop again? Because Spark is just an execution framework. It always needs some other executions, some other storage cluster. Of course, this Spark is not only for Hadoop. The Spark can run on other clusters. Okay, let me write those other clusters. Spark can run on other clusters like Hadoop, point number one, Hadoop. Of course, we deal our course in Hadoop point of view, Hadoop and Spark combination, and Mesos. This is also one of the cluster. and AWS, Amazon Web Services, which offers hardware infrastructure in cloud computing style. Okay. So Spark is not only for Hadoop, Spark can run on Hadoop, Mesos, and also on AWS. And all these are the different advantages. Okay. Up to now, like any questions we have, let's discuss the questions. And next class onwards, we go for like internals of the Spark. So our next class will be from like Monday onwards. Okay. So Monday onwards, because tomorrow, Saturday, Sunday, I have weekend sessions. So that like Monday onwards, I will continue this session. Up to now, any questions like you ask me, like let's go for the discussion for 10 minutes. And before that, I will save this. I will send you all these screens to you. And also this session is being recorded. This recorded session also I will send to you. Just a minute. Yeah, all of you please switch on your mics.
Sir, for how many days this course will go on?
Pardon? Hello?
How many days will this
Yeah,
be done?
course duration 45 to 50 days it will take. Okay, exact course content I will send it to you. So this is the course like a Spark core programming along with Scala. So first like week to 10 days we will completely discuss with once architecture of the Spark completed. We will go with Scala programming language for 10 days, and after that we go with Spark core coding for another 10 days. So here day means like you can say 1 hour per day. And after that we go with Spark components like Spark machine learning library, Spark graphics, and Spark streaming, and Spark SQL with HQL. So these additional components with SBT, simple build tool, and also Maven configurations, all these things we will see as part of this course. Okay. Total minimum it will take 45 to 50 hours. That means per day 1 hour schedule. Even some days if time favors us, like we can go if all like for all of the us if time is favors, like we can go for little more time. Okay, like this. Yeah. Any other questions? A course content I will send you to all of you. Okay, and this recorded daily, every day, these recorded sessions also will be sent. Even though someday if you miss the things, okay, you can go through the recording, and also like if you miss some of the session, if you need more clarity, still I have so many other batches for this Spark Online. I will connect through their classes also. Okay, because in my ID supports up to like 25 people without any disturbance here. You can go through the class. Yeah.
Can can the timing will be changing, sir? Of it's instead of 7:30, it can be possible.
Yeah, like by Monday, at least by Monday only we try to connect in this time only. Monday we will confirm it. Huh? So
Okay, sir.
Monday 7 to 8 only we will sit. Okay. And Monday we will finalize it. Not a problem. It is 7:30 also not a problem. Okay. But whatever it may
Okay,
be,
sir.
we will confirm it by Monday.
Okay.
Yeah,
Yeah.
7:30 would be great.
Yeah. Yeah. Most of requests also like 7:30 or 8 like that. So Monday we will go with the same timings 7 to 8, and Monday we will finalize it. Okay. From Tuesday onwards, we went to sit by 7:30 or 8 like. By talking with all the people, we will finalize it. Still any questions?
Could we
Pardon? Some voice disturbance. Hello?
could you send us the fees details and stuff?
Yeah.
Email.
So those things like Sushita and these people will speak with you. Okay. Tomorrow they will follow up with you about the commercialities. Okay. So now I will send these screenshots and also I will send this recording to you now. Okay. Remaining details like Sushita will follow up you. And also course content I will forward you by tomorrow evening. Okay, what are all the major things we are going to deal in the as part of this course? All these things I will discuss. Okay.
I have one question.
Yeah, please.
Apart from this, if we want to learn only Kafka, I mean, is there any possibility?
Yeah, yeah. There is a possibility, but up to now, very few inquiries. Within 1 week, like we will gather more inquiries for the Kafka, and also like we will try to engage one more session for the Kafka. Okay, very soon. Okay, you just you send me email. Okay, already have my email ID, right?
Right.
Okay, send me email that you need Kafka by putting that subject. Okay, so that I can plan you when our max to max like 4 to 5 days only the Kafka batch will also be started. So then I will inform you. I can connect you. Maximum next week is my next weekend. It will be started. Kafka batch will also be. Okay. So you just send me mail. Like later we'll speak the details.
Sure. Thank you.
Yeah. Yeah. All of you. That's it. Yeah. So any questions or any queries, you just feel free to mail me. Okay. And to all the people, like I will send this recording also. Okay. Okay. All of you. Good night.
Okay.
Yeah. Bye. Thank you very much. Thank you.